This is a video on image editing for CIS 1, Chapter 8. And I want to talk a little bit about the different types of images that we have and also what comprises an image. And I start the screen here with a nice picture of a couple of windsurfers at our own Cape Mendocino here in Humboldt County. But we need to start, when we talk about images, we need to start with pixels. And as you might be aware, this term should be a bit of a review. I believe it was covered in chapter 1 or 2. But anyway, pixel is a contraction for picture element. And it's basically a single point in a graphic image. This is a great graphic image here on the right-hand side of the Spirit of 76 that was done with jelly beans. And one jelly bean would be a pixel. And so it's just kind of a great representation. And so if you have that image of jelly beans or a light bright where you put the little light pins in to make an image, you've got the right idea. So a couple of terms we want to talk about. One is pixelization. And pixelization is when you enlarge a digital image enough that you start to see the actual pixels. So here on the far right, we see a picture of a doll's face. And as we enlarge a component of that doll's face, for example, the eye, you can actually start seeing this pixelization. You see these squares or the actual pixel elements. So we'll see about how we can kind of control that a little bit. So another factor or term that we have to deal with when we talk about images is the color depth. So the color depth is how many colors can I have in my image. So imagine back to that Spirit of 76 where you've got jelly beans. You have a finite a finite number of colors of jelly beans that you can use to create an image. So that's your color depth. And we use bits to represent our color depth because as we talked about a couple of weeks ago when we talked in chapter 1 and we did binary, we realized that bits allows everything is stored in zeros and ones in the computer, which includes our images. So all the colors and the pixels are all represented by zeros and ones. So when we talk about colors, the more bits that we use to represent colors, the more colors we can represent. So if I only use 1 bit per pixel, I only get 2 colors. If I use 2 bits per pixels, I get 4 colors, 3 bits, 8 colors, etc. And we talked also about, the bits create patterns. And that's kind of what we're dealing with here. So if I have 1 bit, my image can basically be black and white. It's two colors. And so that's what a picture of a leaf would look like. If I have 2 bits, then I can have 4 colors. And you'll recall that there is a pattern. So we can have, with 2 bits, we can have 4 unique patterns that I'm drawing on your screen now. And that's it. And then we have to start repeating ourselves. So each unique pattern is assigned a particular color, and hence our color depth. So back to our leaf picture, we saw what it looked like with 1 bit. So with 4 bits, I can have 16 colors, and I start to see things that look a little more realistic. But you look down here at the leaf, and you see the textures we're trying to create with the dots. If I go to 8 bits, you can see that I'm starting to get a little bit more definition. That same leaf, now we're able to kind of do the shadowing and contours, looks a little bit more realistic. And that's because with 8 bits, I can have 256 different patterns or colors. And then we look at that same leaf here with 16 bits, and it's getting even more defined. And the water droplets are another area to kind of look at. Look how realistic that looks, a little less so, and then even less so. And with 16 bits, I can have 65,536 colors. So another term, so we have pixelization and pixels, we have color depth. Another term is resolution, and that refers to how clear or sharp an image is. And that's basically the number of pixels that we have in an image. So if we have an image that is 2,048 pixels wide and 1,536 pixels high, then that particular image contains over 3 million pixels. 3.1 megapixels is how we would refer to that. So that's a lot of jelly beans in our particular picture. So resolution and image quality. One of the things that we want to do is we want to use the minimum resolution required to get the maximum quality. And the reason for that is is the higher our resolution, the more memory something takes up, the more storage our pictures take up. And today with smartphones that have 16 megapixel cameras, we just are able to create these huge images. And it's a lot of wasted pixels, to be honest with you. And we'll see why in a second here. Because basically we need 200 dots per inch for a reasonable quality print image. So if you're going to, and in fact, if you're going to just simply look at the pictures on a screen, 72 dots per inch is basically what you get on a typical computer screen. And then compare that, so if you want to print, you need a little better resolution. You want about 200 dots per inch to get a decent looking print image. What the higher resolutions give you, like these 16 megapixel, 12 megapixel and up cameras, is they allow you to take a very small piece of that image and then blow it up to a large size. So that's the advantage of that. So the size, the printed image that you want or desire, that determines the resolution that you're going to need. And today, a resolution in a camera is not an issue. It's actually the opposite. I don't know if you've ever gotten a email from somebody that says, hey, check out this picture, just had a great sunset at the beach. And you have to actually scroll 3 or 4 times across your screen to get the whole picture. That's because they took the picture at, let's say, 12 megapixels and simply uploaded the whole thing at a very high resolution. It was very, very large, in the million of bits. And your screen can't even display all the pixels in one screen size. It has to actually scroll across. But anyway, so let's look at this idea of pictures and resolution. So if you want to print a 4:6 image, that means you need 200 pixels per inch times 6 inches. So that's 1,200 inches for your height, and for your width. And then you need 200 pixels per inch and 4 inches high. That gives you 800 pixels. So if we multiply those together, then that means I need just a tad under 1 megapixel in size to print that image, to get a very nice looking 4:6 image, which is a fairly standard picture size. If I want an 8:10, which is a very typical frame size, again 200 pixels per inch, 8 inches wide, that's 1,600 pixels on the horizontal. 200 times 10 inches tall, that's 2,000 pixels on the vertical. Multiply those together and I get 3.2 megapixels. So that means with an old camera you can probably get in a garage sale for a quarter, that's 3.2 megapixels, you can get a very, very nice 8:10 image. You also want to look at this if you're going on somebody's screen, and you look at a typical resolution for a screen based on the height and width, or actually the pixels on their width and the pixels on their height, and that can help you determine how big you want that image to be on somebody's screen. You want it to take up the whole screen, it's going to need more pixels. If you just simply want a simple maybe 3 inch by 5 inch, you're going to need less pixels. So how large of an image can you print? So that's another way of looking at it. So again, these pixels per inch, that 200 is a great gauge. Let's say you've got a camera, an old camera that's 5 megapixels, just for the ease of the calculation. Then 5 megapixels, that can give you a resolution of 2,500 by 2,000. And remember, megapixels is million. Mega, that prefix is million. So I can take that 2,500 pixels on the horizontal, divide it by 200 pixels per inch, and I get 12.5 inches. Take the 2,000 pixels on the vertical, divide that by 200 pixels per inch, and I get the number of inches tall. So you can, with a 5 megapixel camera, the max image you're going to be able to get is 10 inch by 12.5 inch. So again, the advantage of having the large pixel cameras these days is the fact that you can zoom in on one particular piece of it, blow that up, and not end up with the pixelization as we have here. So there's 2 basic types of images I want to kind of, the last part of this little discussion I want to talk about. One is called bitmap or raster graphics, and the other are vector images, and both are very different. So bitmap is very simple. It's simply a collection of bits, kind of like we've been talking about with your photographs. Most of your photographs are a type of bitmap graphics. And it's just a matrix of color pixels. And if you, as I mentioned earlier, if you kind of hone in on one particular area of that image and you blow it up, you get that pixelization. So the other advantage of having that very high resolution of large resolution cameras is you can hone in on something this small in your picture, and when you blow it up to an image size, it still has some clarity to it. So here's an example of a very small picture. It's very clear in this small size, but if you were to blow that image up, which I can't do here, but if I were to blow that image up on the screen, let's see if I can get a copy that I can blow up and show you. So here we go. Now I've got it. Now I've got it selected. Now if I blow that up, because it's bitmapped, notice I get that. I get the pixelization. It becomes very blurry, and that's because it's a bitmap graphic. So then our next graphic is a vector. And basically, vector graphics is just that. It's just a collection of lines that are described with mathematical formulas. So they're based on vectors, those straight line segments. So the difference is when you blow up a vector graphic, I have a very small image, I make it larger, and then I make it larger yet, I don't lose that image quality. Now the difference is I don't get true life photographs. They're more drawings and illustrations that are used with the vector images. But here's an example. I can take this particular graphic, I can make it very, very small, and it keeps the image quality. I can make it very, very, very large, and again, I don't get that pixelization. And that's because it's that it's the vector graphic characteristics that are basically, it's just recalculating the vectors that it needs to draw for that image. So it keeps them very, very clean. So you can actually try this. So you can do a little bitmap experiment. Find a small bitmap image on the internet. Like our web page is great. We have a lot of very small images. And you can copy and paste it into PowerPoint or Libre Impress, and then enlarge it just like I did. And you'll see that pixelization piece of it. And with the vector experiment, most of clip art is vector graphic that we have that's available in PowerPoint and Impress or out on the web. Image type things like the baseball player I had in the last slide. And then you can do just exactly what I did and make it larger and smaller, and notice that you don't lose any of that image effect. So try that to really kind of help you cement that the differences between those two types of graphics in your mind. So that wraps up our lecture on images, and if you have any questions, shoot me an email. I hope it was helpful.